Okay, Assalamualaikum semua. So today kita nak revise balik Kirchoff'S Law. Okay. So before we start, let us recall the purpose of Ketchup Law. We want to find V is either E, V, I or R for complicated circuit. Okay. So for complicated circuit. Right. Okay, so what is complicated circuit? So a circuit that has more than one EMF. Okay, so let's say we have a case here. We have a circuit with 3 EMF. Okay, E1, E2 and E3. Okay, so one of the technique to use the Kirchoff's law that I have introduced to you in class was 3D and 3E. Hopefully you still remember. So 3D means you have to draw 3 directions. And 3E means you have to get at the end 3 equations that we are going to solve to find our is either current, voltage and resistance. It depends on the requirement of the question. Okay, so we use 3D, 3E. So the first D is direction of current. Okay, that's supposed to be from positive to negative of the terminal battery terminal. But for this case class, we have already got the current. It is already prepared for us. So we have I1, I2 and I3. Okay, so I just would like to remind you that one wire will represent one circuit. So for this example, this is one separate wire. Okay, so one separate wire. This is green. This is for I2. And then let us take another color. So this is for one wire. So this is for I3. And let us take another color. We have orange here. So this wire is for I1. Okay, so we have 3 wires, meaning alright. So in this case, the first D is already drawn. So I1, I2, I3 are ready in the question. And the second D is for direction of EMF. So the direction is supposed to be from negative to positive. So at every EMF we have here, you have to label negative to positive, negative to positive, negative to positive. Okay, so for the time being, I will try to make sure everything is neutral so that you won't get confused with so many directions. Okay, so this is direction of EMF. And then the next D is direction of loop. Is either clockwise, or anti-clockwise, or anti-clockwise. So how to determine? It's actually up to you. So you choose, you are the one that need to choose. So I choose for this case, I choose for my left circuit, I choose clockwise. Label loop 1. And for this one also, for loop 2, I also use clockwise direction. Okay, next we want to get the 3 equations. Okay, so these 3 equations is for junction rule. Okay, it's for junction rule. Okay, one equation from junction rule. And the 2 equations, the 2 other equations is from loop rule. Okay, from loop rule. So 2 equations we're going to get at the end. Okay, we start with junction rule. Okay, now we start with junction rule. So junction rule, we will generate, we are going to look at the junction. Okay, at any junction, So at any junction, so let's look at this junction for example. The current in is I1, the current in is also I2, but I3 here is out from the junction, I3. Sorry, I2. I2 is out of the junction. So our equation now is summation of I in is equal to summation of I out. So it's equal to I1 plus I2. The total current in is equal to I1 and I3. So I1 plus I3 is equal to I2. So this is our first equation. Now we have got our first equation, three direction. Okay. Next, we want to get the direction for loop 1 and loop 2. Okay, now we apply loop rule. Okay, we apply loop rule. So loop rule, we do it by loop. So we start with loop 1. Okay, so before we generate the equation, okay, so we start with loop number 1. So loop number 1 is the left one. So we set up as loop number 1. Okay, so before we generate the equation, we need to know class the sign convention class. Okay, sign convention for EMF and also for IR. Okay. So before that, I would like to introduce, or I would like to tell you that we use the loop rule. So the basic equation is summation of EMF is equal to summation of IR for every loop. Okay, so what are the sign conventions that we need to know is, okay, or are actually, we have a few. So first, for EMF, if we have our direction of loop is equal to the direction of EMF, okay, so this is our direction of EMF from negative to positive, okay, and this is direction of loop. So now these two directions are equal, meaning our E is going to be positive. But in opposite, if we have the second case that our direction of loop is in opposite to direction of EMF, okay, so this is our loop, this is our EMF from right. So if we have this case, our E is going to be negative EMF, okay, negative E. And for IR, it's just about the same. So rule number 1 is, if we have direction of loop, okay, so you can see here that our loop, we always compare direction of our loop with direction of current, okay, IR. So this is your resistor, and okay, at first I will have the equal direction. Okay, so this is our direction of current. Okay, let's say current flowing is in this direction. So in this case, it has same direction with the loop. Current and loop, we compare current and loop. So for this case, our sign convention is positive IR. Okay, positive IR. And okay, you can guess what is if we have, what if we have opposite direction. Okay, so this is direction of loop. Okay, this is direction of loop, and this is direction of current that flows through a resistor. So if you compare these two, direction of current and direction of loop is in opposite, so we are going to have negative IR. Okay, so this rule of sign convention you have to know before we do the equation. So class, let's start with loop number 1. Okay, class, loop number 1. So loop number 1, we start with summation of E. Okay, so we have E1 and E2 for loop number 1. So we compare with the direction of loop. So for E1, it has same direction. Okay, this one upward and upward. So we have positive 10. And for E2, we have opposite. So this is downward, this is upward. So it's going to be negative 5. Okay. And for resistance, okay, if you look at this left circuit class, we have two resistance, meaning you are going to have two terms of IR. I1, okay, IR. So I will directly convert the number. So we have for the first resistor is R1, 2 ohm. So the current that is flowing through through R1 is I1. So I1, direction of I1 to the right, and direction of loop is also to the right. Okay, it's also to the right. So it's going to be positive I1 times the resistance. Okay, and then we look at the second resistor. So this is our second resistor. Okay, so direction of current through this resistor is I2 to downward, and also direction of loop is also downward. So again, it is positive. Okay, so we have I2 flows through R2. Okay, now we simplify the circuit. Finally, we get 5 equal to 2 I1 plus R2. Our R2 is 4 I2. So this is your second equation. Okay, settle our our second equation. Okay, now we want to generate the third equation class. Okay, so the third equation, okay, so the third equation is going to be, alright, it's going to be from loop 2. Again, we start our equation with summation of EMF is equal to summation of IR. Okay, summation of IR. So this time we are referring loop number 2. So I try to make it clearer. So we have a new circuit here, let's say. So this is to the right. This is to the right direction of EMF that we have drawn just now. Okay, so this is our loop 2. Okay, again we use this sign convention rule, then we can have the equation. So for loop 2, we have two EMF, E1 and E3, sorry, E2 and E3. Okay, so now we write down the equation. Okay, we write down the equation. So we have this one is having same direction, so it's going to be positive 5, and this one is opposite direction. One to the left, loop is to the left, EMF is to the right, so it's going to be negative 8. Okay, what about IR? Okay, again in loop 2 we have two resistance, so R2 and R3. So we compare the current that flows through the resistance. The current that flows through R2 is I2, and the current that flows through R1 is I3. Okay, so we start with I2. So I2 is downward and our loop is upward, right? So it is negative. Okay, negative I2 R2 later on, or you can straight away substitute. Okay. Negative I2 times 4. Okay, and if we refer the R3, so R3 is, again this is our direction of loop, and this is direction of I3. So again it is in opposite, so negative I3 times 5. Okay, I3 times 5. Now we simplify the equation. So it's going to be negative 3 equal to negative 4 I2, negative 5 I3. Okay class, so everything is negative. You can just convert it into positive. Okay, and now we get our third equation. Okay class. So the next thing to do is calculation to get the final value of I1, I2, IR. Okay, so how to start? First, we need to rearrange the equation class. Rearrange the equation because we want to put it in a matrix form. So it's going to be 1, negative 1, 1, 0, 2, 4, 0, 5, 0, 4, 5, 3. So this is the matrix form that you can have. Then using these numbers, you insert in your equation, in your calculator. Okay, next you'll see how we press the calculator to solve the Kirchoff's laws. Okay, so that's all from me. Hopefully you understand what I have explained just now.
Okay, ini adalah cara-cara untuk mengira Kirchoff'S Law menggunakan kalkulator 570 ES+. Mula-mula anda tekan mode, ambil nombor 5 iaitu equation dan nombor 2. Okay, jadi anda akan nampak seperti ini, A, B, C dan D. Okay, mari kita ambil satu contoh. Ini adalah equation, anda akan masukkan ke dalam kalkulator dari kiri ke kanan. Jadi mari kita masukkan. Tekan sekali lagi, anda akan mendapat jawapan X, Y dan Z. X ni adalah jawapan yang pertama, Y yang kedua dan Z adalah yang ketiga. Itu sahaja, terima kasih. Dah.